Hi friends, welcome back on our YouTube channel. Today in electronics, we are going to discuss about optoelectronic diodes. Now, what is optoelectronic diodes? If optics is involved in electronics, then such type of device is known as optoelectronic device. So here we will discuss about optoelectronic diodes. Now, here we will discuss about light emitting diode, that is LED, photodiode and solar cell. So these three optoelectronic diodes we will discuss in our current lecture. So first of all, light emitting diode, that is LED. Now LED. First of all, principle of LED. In simple PN junction diode, the energy bands are indirect. Simple PN junction diode are germanium and silicon type diode. So, if diodes are made up of these type of semiconductor, then their energy bands are indirect. When these diodes are forward biased, then the recombination of electron holes across the junction starts. Now, we connect simple PN junction diode in forward biased, then what happens? The recombination of electron hole across the junction starts. When electron jumps from higher energy level to lower energy level, then it emits energy in the form of photon. In simple PN junction diode, this energy lies in invisible region, so we cannot see it. So when electron jumps from higher energy level to lower energy level, then the energy emitted by electron in these diodes will be in the form of heat, and hence we cannot see it. But in some special type of semiconductor, the energy bands are direct. These semiconductors are gallium arsenide. When these semiconductor diodes are forward biased, then what will happen? In the process of recombination of electron hole pairs, the electron jumps from higher energy level to lower energy level, and the energy emitted in this case will lie in visible region, so we can see it. The energy emitted during this process lie in the visible region and is clearly seen due to transparent material of crystal. Since these diode, which diode? The diode made up of gallium arsenide semiconductor. So these diodes emit light energy on forward biased, hence they are known as light emitting diode. So this special type of diode emit the light or emit the energy when electron jumps from higher energy level to lower energy level, and this energy lie in visible region. So these diodes are known as light emitting diode. Now, construction of LED. In LED, generally we use gallium arsenide or indium phosphide. So this is our arrangement of LED. Here we have electrons and here holes. So when electron jumps from higher energy level to lower energy level, then in this process electron hole recombination starts, and this is the light or energy, because here electron jumps from higher energy level to lower energy level, so it emits energy, and this energy is in the form of visible light. So this light can be easily seen, and Here we have transparent surface, so the light which emitting during this process can be easily seen due to this transparent surface, and this is the symbol of LED. Arrow in outward direction showing that light is emitted in such type of diode. A means anode or K means cathode. In these diode, N-type semiconducting layer grow on a P-type substrate by diffusion. Now, this is our arrangement. After it, a thin layer of P-type material is grow up on N-type layer. At the external sides of these layers, a thin metallic contacts are attached which are connected to cathode, and cathode is indicated here by K and anode is indicated by A. So at the external sides of these layers, a thin metallic contacts are attached which are connected to cathode and anode respectively. So this is our cathode and this is our anode. The whole arrangement is placed in a transparent plastic cover or envelope. The color of plastic cover depends on the light emitted by diode. So which type of light is emitting by the diode? The color of plastic cover depends on this. This was our circuit symbol and this is also circuit symbol, and this actually shows the transparent plastic envelope. LED is always used in low forward bias. The wavelength emitted by the diode depends on the percentage of arsenic in gallium arsenide phosphide diode. So, what is the amount of arsenic in gallium arsenide phosphide diode? The light emitted by diode depends on such percentage of error of arsenic. The common formula is gallium arsenic 1 minus x px. So we just put here the value of x and we get the formula for such diode or such LED. Gallium arsenide gives infrared light and gallium phosphide gives light of blue color. If the energy band of above diode is 1.8 electron volt, then we get light of red color. And if this diode is doped with nitrogen, then we get light of all the colors ranging from yellow to green in visible region. So the light emitted by diode depends on the energy band of the diode. The wavelength of emitted light is given by lambda equal to hc upon Eg. Here h is Planck's constant, c velocity of light, and this Eg is our energy gap or band gap. Since h and c are constant, so if we put the value of these two constant, then lambda equal to 1.26 upon Eg in terms of micrometer. If we join 7 segments of LED, then we can get any number from 0 to 9. So here we are showing the 7 segment LED. This LED is represented by A, this is B, this one is C, D, E, F and G. This is the connection of 7 LED, 1, 2, 3, 4, 5, 6 and 7. So if we connect 7 LED, then we can create 7 segment, and here we are showing a digit 4. So to get 4, F, G, B and C LED are lighted up, and if we want to get number 2, then 2 is our this figure. So A, B, G, E and D. So if A, B, G, E and D LEDs lighted up, then we get number 2. So in this way we can get any number from 0 to 9 by using 7 segment LED. Now uses of LED. LED are used in calculators, it is used in watches, used in platform signals, used as a pilot lamp in electronic device for showing on-off position, and also used in optical communication system. So these are the uses of LED. Now next optoelectronic diode is photodiode. So photodiode is a PN junction diode which is made up of photosensitive material. If the material is photosensitive, then when photon or light falls on the photosensitive material, then we get light. It is connected always in reverse bias. So this is our photodiode. So this is the symbol of photodiode. It is clear from this symbol that light falls on this diode. So this diode is actually made up of photosensitive material. Now P terminal of photodiode is connected to negative terminal of battery and N terminal to positive terminal of battery. It means here photodiode is connected in reverse bias. So photodiode is always connected in reverse bias. Now it is clear from this figure. This is the figure between light intensity and current. So as the intensity of light increases, the amount of current flows in this circuit also increases. So with the rise in light intensity, the amount of current also increases, and after a certain value of light intensity, if we increase the light intensity, then there is no increment in the current. So this is our saturation position. Now, principle of photodiode. It is based on the electric conduction of light when electromagnetic radiation of suitable frequency, and this frequency lies in visible range. So when electromagnetic radiation of suitable frequency falls on the surface of semiconductor, its conductivity changes. The phenomena of variation in conductivity of semiconducting material due to light is photoconductivity effect. What is photoconductivity effect? The phenomena of variation in conductivity of semiconducting material due to light is photoconductivity effect, and the diode in which this phenomena used is known as photodiode. So photodiode uses the photoconductivity effect. When light falls on the surface of conductor, its conductivity changes and the electron moves from valence band to conduction band, and hence the current flows in the circuit. It is found that the amount of current increases with the intensity of light. So as the intensity of light increases, the amount of current also increases. The maximum current is our saturation current, and the current which flows through the circuit in the absence of incident light is dark current. So dark current is a current which flows through the circuit in the absence of incident light. It means when there is no fall of light on the photosensitive material, then also we get some amount of current, and this current is known as dark current. Now we increases the amount of intensity of light, then the amount of current also increases, but after a certain value. If we increase the intensity of light, then there is no change in current. Such maximum current is our saturation current. This was our diagram. So this is our saturation current, and here we have dark current. Now construction. To construct a photodiode, we use a photosensitive p-n junction diode, and this photosensitive p-n junction diode are enclosed in a cover whose one surface is made up of transparent material. So the light can easily enter into the diode. So photosensitive p-n junction diode are enclosed in a cover to construct the photodiode, and one surface of this cover is made up of transparent material. A convex lens is also fixed to this surface so that the incident light can be focused. So here we have a convex lens, and in this cover we have photosensitive material. So when light falls on it, then whole light focus, and this focused light falls on the photosensitive material of diode. The rest of sides are blackened. This was our diagram. So here we have photosensitive p-n junction diode. It is connected in reverse bias. Here we have a convex lens or focusing lens. Now electromagnetic radiation of suitable frequency, and this frequency lies in visible region. It means the visible light falls on this lens, and this lens focuses whole light, and this focused light falls on this p-n junction diode, and we get current. This is the circuit symbol of photodiode. Now, uses of photodiode. It is used in sound film, used in computers. Photodiode also used in tapes. It is used in reading computer cards. Also, photodiode used in light driven switches. So these are the uses of photodiode. Now, next optoelectronic diode is solar cell. Now what is solar cell? It is a PN junction diode which converts sunlight directly to electricity with the large conversion efficiency. So solar cell converts the sunlight directly to electricity and its conversion rate is very high, or conversion efficiency is very high. This is our solar cell. Sunlight falls on this solar cell. When PN junction diode is exposed to light, photons are absorbed and electron hole pairs are generated in P and N side of the junction. The electrons and holes that are produced over a small distance from the junction reach the space charge region W by diffusion. So this is our space charge region, and the electron holes generated by sunlight reaches in this region. The electron hole pairs are separated by the strong barrier which exists across the region W. The electron in P side slide down the barrier potential to move the N side. This was our diagram. Similarly, the holes in the N side slide down the potential barrier to move up to P side. So what happened here? The electrons in P side slide down the barrier potential to move to the N side. So electron move towards N side, and the holes in N side slide down the potential barrier to move up to the P side. These holes move up to the P side and these electrons move down to the N side. When PN junction is open, the accumulation of electron and hole on the two sides of the junction give rise to an open circuit voltage, and this open circuit voltage is VOC. So VOC is our open circuit voltage. If we connect a resistance across the diode, then a current will flow in the circuit. The current flows as long as the diode is exposed to sunlight. So the amount of current flowing in the circuit up to that time up to which the diode is exposed by sunlight, or the sunlight falls on the diode. The magnitude of current is directly proportional to the intensity of light falls on the diode. So higher the intensity of light, higher will be the amount of current. Now, uses of solar cell. Solar cells are mainly used in satellite because we cannot connect circuit from here to satellite. So solar cells are mainly used in satellite, and this cell exposed by the sunlight. Also, it is used in space vehicles. Solar cells are used in solar street light. So during daytime, these solar cells exposed to sunlight and store energy, and this stored energy is used during night time to lighting the solar street light. So here we end our session. You can get the notes of this lecture and the link of that notes are given in our description box. So you can directly click on that link and get the notes of this particular lecture. So goodbye.